How's it going, everyone? Julián Gonzalez here, and today we're going to talk about is on React Performance, which is a course taught by Steve Kinney. He is a head front engineering at Temporal, which is a durable execution platform. So this is some sort of like a orchestration systems, but for applications. So Temporal actually is an open source that allows you to do that. And the entire reason of looking at the React Performance is to look at how can we write React applications in the most performance way. Because once you're able to now look at how React works behind the scenes, you will end up to facing all of this challenge, especially perhaps at the first time you were able to write your application's performance, but others, sometimes you don't, you heard that. And as a way to prevent that, you first need to understand how React works behind the scenes, and then you're gonna now develop and build a toolset for diagnosing these performance issues that will give us a set of best practice to come along. So now you can solve those kind of problems without any issue. So it's like pretty much like untying a knot. So you know now what is the technique that you need to, what are the threads that you need to pull and how to do that. So that's one of the reasons why we are looking especially here React Performance. And in fact, that's the goal of this course, right? So shout out to Steve Kinney for that, which is learn how to write these React components in the most performance way possible. And these specific things that we're gonna see here is like, okay, because we're gonna see now how to develop, we're gonna see how to build this tool set for diagnosing performing issues by understanding now how React works. First, we're gonna see how can we structure our components hierarchy to make sure that our app perform as performantly as possible. Learn how to memorize component using building in React tools, as well as look how to load code just as you need on demand using is the lazy. Then look at concurrent features of React 18, for example, like low priority rendering, something that Brian Hall actually mentioned. For example, use deferred or use deferred in use transition, okay? And then how you can use the profiler to diagnose and solve performance issues. But this course, which is organized in this way, you have the introductions, the React rendering, reducing renderings, context, important, suspense and transitions. And this course is for people who are who know about how, or who want to know how React works. Okay, so you want to build a tool set, something that I mentioned at the beginning that to me was very, very, very important. Okay, you want to build a tool set for diagnosing performance issues in React, all right, and learn some of the best practice when writing React apps, which is exactly what we are doing here. And the way how you now not only that you want to know how React works, and then once you know how that works, you're going to develop or build some tool sets that allow you to diagnose these performance issues in React, and then you come up with best practice to solve them. And this three main aspect is this storytelling, is understanding how do we get here, how now I am looking right now at the React Performance as a way to understand it, as a way that any time that I need to actually solve a client problems with their React app, I can see, okay, what's the problem? First, focus is on the problem, not on trying to solving or to finding problems. It's like, what is the problem here? So focus on the problems. And React is decently fast out of the box. So most performance issues are usually the accumulations of small, tiny things that happened 6 months or a year later, and it's possible to get a performance issue. Yeah, even though that it's possible to get a performance issue quickly, okay, but you will see that much more faster, and it is easy to fix. So then you will say, hey, who made the last commit here? You know, and then from there you can do the reverse engineering for that. And a lot of the time people start joking, and to me that's not a joke, bro. That perhaps I'm too old for this, or someone that actually is taking deadly serious this. When people started to joking about that they need to rewrite the app, until that is not funny. Again, another reason why am I looking at the React performance. Okay, and not only improving my technical communications, but also my hard skills. Is as a way to figuring out what it's doing, how it's doing, what are this set of tools to use for diagnosing these React performance issues, and then come up with this best practice as a way to untie this knot. So because you can think that all of these particular techniques can be applied to small applications to bigger ones. Okay, so the only thing that you need to is apply them over and over until you get now. It's pretty much like untying a knot or untying a big knot. So you start to pulling all the threads with the technique that you know. And I really love about this. Totally really love about this. Yep. Yeah, oh my God, yeah. yeah. All right. So now that we know how do we get here, and the reason of looking now at the React performance as a way to now look at how you can write performance React components. Okay, so the reason of looking at that is when you are new to React, or if you don't know how React works, you usually make some mistake or actually hurt the performance of your applications. So instead of doing that, to prevent and to save you time, valuable time, so here we're going to see how React works behind the scenes, understand how React works behind the scenes, what is the data structure that is working as a way to rendering all of these components. All right, is a tree data structure. All right, and then now build exactly and then now build is a tool set for diagnostic performance issue in React apps. Okay, so then you can come up with some best practice when it comes to solve those issues. So pretty much like you are untying a big knot. So you started to pull in the right threads with the technique that you already know. And that's the entire reason of doing this. Oh, yeah. Totally. Oh my God. Yeah. So the value proposition here of performance is that, which is one of the golden rules, Steve golden rules. Okay, is that not doing stuff is better than not doing stuff is faster than doing it. Okay, in the case of performance, and this is also that you can apply to your life. So not doing stuff, or not doing not doing priority stuff. Talk about priority here. Not doing priority stuff is faster than doing it. Again, the reason why I'm recording this series of videos. All right. Cool. So there's a corollary to that doing stuff later is better than doing it now. Part of the low priority rendering, or deferring task, delegating task. So at a high level, what we're going to cover is catching and memorization components. Okay, structure your components React app and React 18 concurrency feature. But this is now the diagnosing step for performance issue. So this is the slide I'm going to show you at the end. All right, if you can solve a problem with how you shape your components and hierarchy or state, do that first. So now that we know, so we also gonna know is how now React rendering working behind the scenes, as a way to say, hey, this is the first element that you're gonna render, and from there you can now render children and so on and so forth, right? Like a tree. But this particular slide is something, this is part of the tool set, okay? For diagnostic is performance issue. First things first, ask yourself, or ask for the company, whatever they have, is like, hey, what is the problem? Okay, hey, this component is not get rendering. Hey, this component is showing something that we don't want to. It's like, just start with the problem first, and then you can move on to identify, hey, this is a performance issue or not. But start with the problem. All right. So yeah, that's it. And quite frankly, that's the introduction of the React performance. Okay, and this is interesting because it's not only specific for React performance, but also for performance in general. I will argue that it's performance in general. Why is that? Because once you understand how now a thing works, in this case React, or your body, your human body, or your human minds, or your human cycles, all right? So your circadian rhythm, for example. So once you know how a particular stuff works, even though JavaScript, okay, then you can build a tool set to diagnose performance issues, and then you come up with best practice. And these best practices are remedies, are like untying a big knot, because now you're starting to pull in the right threads with the technique that you know. And one of the great things is that today we're going to see how can we apply these techniques to small applications that are applicable to large code bases. Okay. All right. So now with these introductions, okay, and what are the tool set here that we're gonna see as a way to make sense of how do we get here, all right? Or what are the tool set that will allow us to identify React performance issues and how to solve them, okay? Is that first, focuses on how the React component, focus on the component hierarchy, okay, or states, okay, the component hierarchy or state. Why is that? Because at the end of the day, React is all about rendering components. I get a view out of this that I want to generate. I want a state that I want to generate view out of this. All right. So focuses on the component hierarchy and or state. Do that first. If not, then you can take a look now at the memorizations. Okay, it's a solid strategy only if the cost of checking pays for itself with the time you save rendering. So it is not, if those memorizations are at the bottom of the tree, it's honestly not needed to evaluate that. It's quite frankly, it's irrelevant for that. However, if they are now at upper levels or closer to the root elements, then it is time to consider and evaluate that. Then you go with the suspense API to progressively load your applications. Okay, and more good stuff will come soon. All right, with the suspend API, it allows you to exactly. This is now a feature in React, the suspend API, that allows you to load things progressively, or progressively load certain part of your applications. The suspend API, and then we got is a transition API, which is there for you when you're really in a pickle. The transition API. Okay. But again, so based on this toolset that Steve Kinney is giving us, is like, this is where you must start, or this is where you should start. No, this is where you must start if you have performance issue. Okay, and how to avoid those performance issues is by knowing how React works. And let's go to do that right now. So React rendering here. Inspect performance with DevTools. Install React DevTools here. So we look at now what are the features that React DevTool provide for us, which quite frankly was quite interesting. Yeah, I must admit, totally. I must admit. So for example, npm star here. And now how npm star, why you launch this? Exactly. Okay. And there you got it, right? It's actually is now showing all of this. Add a comment. It's showing you the entire collection here. Oh, okay. Neighborhood hot takes. First name, last name, username. Okay. So add a user, and you got all of this user as it is. So because now React provide us is the can you see what I'm looking? Yes. Because React now provide us is the component aspect as a way to say, hey, this is more relevant for development. Okay. So here you can see is which are the data that this component is receiving, and it also is telling you, hey, how this component is getting rendered. What is the rendering tree or the rendering hierarchy here? So you got the providers, that in the provider contains several reducers, right? Or several hooks here. Interesting. 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 I think this is show. Oh, like this. Bell Sequique order, and there you got it. Okay. And this is the ID one. That's right. Okay. And inside of this, you can see is the user. Okay. As well as Yeah, they use the users for that. Hasegawa Hiromi and the username. And it left several comments here, like Nemo Sapiens, and that kind of thing. Alright. Was the user Rubello here. Oh, this is the user from this blog. Okay, from this post. And then you have the comment that are made from this user as it is. Exactly. Perfect. Perfect. Alright. Alright, cool. Cool. So now that we look at the data structure here as a way to make sense, and this is in the provider that is being loading this. Alright. This is in the provider that is being loading here. Okay. Good. Because what is relevant for the React performing is the profiler, where you can see is that, hey, let me actually activate this. 1, 2, 3, and you stop. Then of course nothing has changed. So for example, when you started to mouse over elements here, you say, and then go back. Again, you don't see anything different. That's right. So if we hover here, we actually is just moving the icon here, but nothing has been recorded. All right. But now when we're starting to pass our mouse through elements, interesting. Okay. So the profiler, okay, is now enabled when you perform some sort of action. So for example here, let's go now to actually remove this element. And here we're able to see what happened. It's like, hey, who initiated that? When you click there, and also we can take a look now at the component here, and or on the profiler, exactly. It's going to reload this again, right? Clean that up, and we're going now is to remove is a post, right? To see what went wrong. So as you can see here, is like, hey, this now trigger in 5 milliseconds. This now trigger is a context provider. So what happened here is that by running just the remove post, we are actually rendering the entire component, and it's because the way how do we have our tree data structure like this. It's like this component is actually rendering the entire stuff. Okay. The application is not rendering, okay, but you are now rendering is a context, the context provider, as well as that particular post. Okay. Followed by all of the elements that are below that. So perhaps for small posts like this, or small amount of posts like this, is like it's quite irrelevant. It doesn't hurt the performance. All right. But you can start to think when you have now a table with 1,000 rows. Now things are starting to accumulate that. So let's get now to understand
this. Like if you're going to worry about the performance of your application without like at least checking these two things, right? Which is one, are you running in production mode?
Steve provides some quick wins to check before looking into performance. Okay. Which is now inspect performance with DevTools. React rendering. Inspect performance with DevTools. What we can see is this. Component include kits, exactly. Inspect performance with DevTools. Okay, inspect performance with DevTools, like it is. Okay. So here we can talk about is the initial exactly quick wins to check before looking to performance. Exactly, quick wins first, and then we got is the we got first is check that is on production. That is a production build. Check if your app, check if React app is in production. It's in production mode. I think that's quite silly, but it's important. Next one, including checking the app is running in production mode. Exactly. Component including keys. Component including keys. And utilizing the React Dev tool. And use React Dev tools. Oh, give me a second. Ooh, be right back. All right, here we go. All right. Okay, I think this is part of the React rendering. Okay, inspect performance with DevTools, DevTool QA, QI, React rendering cycle, React rendering cycle, React Fiber and rendering QA, as well as find a performance issue exercise. And there you got it. So here we're talking about is React rendering cycles. Okay, so React rendering cycles. Okay, state and life cycles. Using the React.create root document dot exactly as a way to inject this element there, right? And when you set now the set interval tick, but the tick is a function here, but the tick is a function here, that's right, that is telling you that. And this function is interesting because it's now rendering this element, rendering this element, rendering this element, and this one, and this one, and this one. Set interval. And what it's doing behind the scenes is that now you are calling to the callback queue in the browser as a way to, hey, once this 1 second has passed, please evaluate this, please evaluate this, please evaluate this function. Now, of course, you're going to create a new object to that, to a local time stream. That pretty simple, very, very simple. So this actually you learn how to make a clock component truly reusable and encapsulate. It will set up in its own timer and update itself every second. So what it's doing is to wrap this into a clock, okay? And then call this function, root.render. Hey, I want you to now render this, and so on and so forth. However, it is missed a crucial requirement, that the fact that the clock setup timer and updates UI every second should be an implemented detail to the clock. Ideally, we want to write this once and have the clock update itself. To implement this, we need to add a state to the clock, converting functions to a class. Yep, something that I'm quite familiar with, adding local state to class as it is, and how now they convert this from class to functions, and how this is now behind the scenes. What it's doing is to using is the object-oriented programming nature of JavaScript as a way to say, hey, we're going now to access to the property and methods from this base class React component, and behind the scenes what it's doing is that let me now set the prototype, because at the end of the day this is a class, and a class is a special function, and the function has now this is the first class citizen in JavaScript that is callable, and also have this object portion, because at the end of the day in JavaScript everything is an object, and functions are a special type of objects, all right, that have now the function aspect as a way to invoke them, and the object portion as a way to define or have access to the property and methods under the prototype. So what he's doing here is say, hey, let me now set the clock function object class prototype to point to the base function constructor prototype, which is React component here, okay? And also let me now point is the proto reference from this object, okay, to the function constructor. So when you use super, now it can actually run is the proper base function constructor, or base function constructors. You can pass the props, and then you have known the value of this, the property methods from the React component, from that base class, all right, where you can now define is your state as it is. But again, this is the old way of doing this, okay? So adding lifecycle methods like this. So you have component did mount or component will unmount, right? So pretty much this is the way of how, for example, this is using exactly like this. When the component mount, I want you to set the timer here. Is that I want you to actually make this function here, okay, on the component did mount. And then the component will mount, okay, I want you to now clear the interval as a way to not keep, in the case of our timer here, as a way to not using is the callback here, you know, or not using is this resource. Free up memory from that. Cleanup state, right? So we perform our cleanup state is with the component will mount, with the clear interval, or when we return something from the use effect. That's when we do is the cleanup state, all right? And the component amount is something that you do on class. Now, using state correctly. Do not modify state directly. Wrong, exactly. This dot set state, because this is something that they provide you for that as a way to do this. So yeah, pretty much this is it with that. Data flows. And why this is important, component versus inheritance, composition versus, these are docs are all and won't be updated. That's interesting. Go to the React Dev, a state component memory and synchronizing with effects, you know. But this is how the old way of doing things. And then you have the a state component memory and synchronizing with effects. What is this? And then this, right? Adding interactivity, responding to event, state, a component's memory. For example, like this. Is this in Spanish? Okay, this is in Spanish. That's quite interesting. Rendering and commit state as a snapshot, queuing and series of update state. Manual state. Okay, this is describing the UI. Your first component, importing and exporting component, break it up, conditional rendering, all right. And what are the things that you should do, especially when you rendering is when you do this conditional rendering here, as it is. Conditional returning nothing with null. Exactly, it's back. Fully equivalent, exactly. rendering, but what we care here, your UI as a tree. This exactly. This is it. 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 All right. Exactly. Why you are taking so long to actually go and this is the installation. All right. I actually quite new to this. The installation to this. Describing the UI, your first component, importing and exporting component, writing markup with GSX, JavaScript GSX with curly brace, passing props to a component, conditional rendering, rendering list, keeping component pure, and that kind of thing. Ooh. Okay, your first component, but this is now how you can do that with exactly with now the functional approach. Okay, so far so good. Adding a markup, using a component. Exactly. And watch the browser see. What the browser see? Okay, what the browser see. Notice the difference in case. Section is lowercase, so React knows when to refers to HTML tag. And profile node, that is this. Nesting and organizing components, exactly. Components are regular functions, so you can keep multiple components in the same file. This is convenient when your components are relatively small or tightly related to each other. In these files, get crown, you can always move profile to a separate file. You will learn how to do this shortly and about imports, because our profile components are rendering inside gallery. Even several times we can say that gallery is a parent component. Exactly. Common components can be rendered other component, but must never nest their definition. Never define a component inside of another component. They must be very. This snippet above is very slow and cause bugs. Instead, define every component at a top level. When a child component needs to some data from a parent, pass it its props instead of a nesting definition. But this is the recap. Export the component, fix the returning statement, spot the mistake here. Warning, the tag profile is unrecognized in this browser. Do you mean React? You mean render a component? And you should name your functions as it is. And write your own component, like so. So this is okay, importing and exporting components, okay, as a way to now make sense of how you can do that and following the best practice to do that. Remember that at the end of the day, the end goal of this is just to be able to render components. And now, in the case of performing, is to focus on the hierarchy, React hierarchy component. Make a GS file, put the components, and then get it here, and then you got it. Oh, this is how you can import use the native ES model. Okay, default versus namespace versus export. Default versus namespace, exporting an import model component from the same file. But if I want to show just one profile instead of a gallery, you can use the export default function, like so. And on the gallery, you say export default gallery, okay? And then you're gonna render your component as is. Again, this is just as a way to look at now the docs, recognize and get yourself familiar with that and say, okay, this is how they now promote you to follow. Hey, follow these particular guidelines of importing and exporting React components, right? So for example, like this Try out some challenge here. It's like, hey, export the default function button or name function. Export function button here. Usually, they prefer to export that as default. All right. So next, prefer that particular approach. I'm with them. Writing markup with GSX. Okay, GSX is a syntax extension for JavaScript that lets you write HTML-like markup. That's right. So far, no problem, as it is. So we're quite familiar with the GSX. And how now the GSX is, even though that you initially don't like how it's gonna look like, but that's what it is, and that's how we get here. Deal with that, you know. Exactly. Heidi Lamar's to do. Pro tip using GS converter. So a converter, interesting. HTML to GSX. All right. But there is actually no need. It's quite interesting. Transform. Powered by Vercel. Interesting. Interesting. A very interesting tool, by the way. Yep. Interesting. Totally. Yep, a very interesting tool for that. Gettings to go, markdown to HTML. Okay, actually it's not that hard. In fact, they're actually more, well, AI is actually capable of doing this. To Kotlin. All right, that's quite interesting. To sarcastic, to scale a class. Tone, TypeScript. Yeah, okay. Sort scheme. Sort scheme. Sort scheme. Yeah, that's something that I have seen in couple, yeah. TypeScript using its what interface exactly. The sort of difference between interface and types as well. Brought above. OpenAI schema. GS2 objects. Tailwind CSS. Do that. Alright, so way to reuse all of this CSS. Okay, cool. Yeah, that's a very interesting utility. To translate your existing HTML and SVG to GSX converter are useful in practice, but it is still worth understanding what's going on so you can comfortably write your GSX on your own. Exactly. So the using is now this converter as a way to say, hey, you must have is a root element. That's what you can use this kind of thing. So yeah, it's because they need is to actually GSX fragment. It's just a way to actually for the GSX to recognize that it must have a root elements to render this. GSS with curly brackets as a way to now pass dynamic data to that. So far so good, no problem with that. All right, and then Extract the information like this. Write an expression inside GSX curly brace. So as a way to actually is now consume that data dynamically. And then passing props to this, something that I'm quite familiar with. All right. You can define your props for that as a name. And then on the component, you're going to receive that as it is, right? Name, the name ID, the person size, as it is. It's quite interesting that they're using is, for example, this kind of image. Lean line. Oh, interesting. Okay. Katsugo Sharushi. Interesting. Okay. Interesting. Oh my God. What? What the F is this? Holy F, moluscos del agua. Esquitosomiasis. Bilharzia. God damn. Is there any treatment here? Yeah, is there any treatment here? Interesting. It's like a bacteria or what? It's a parasite. Bilharzia. Holy fuck. All right. And Lin Janin. Oh. All right, that's quite interesting. Material engineer materials, English. Mother of the semiconductor materials. Oh. Also Chinese electrical engineer, materialist scientist, physicist, and politician. What? Politician? Why not surprised? She is called the mother of aerospace materials and the mother of semiconductor materials in China. In 1976, she returned to China and began her research at the Institute of Physics, CAS. Then she then moved the Institute of Semiconductor CAS and spent her research life there. Among her many contributions include manufacturing China's first monocrystalline silicon and the first monocrystalline furnace used to extract silicon in China. She laid the foundation of developing microelectronics and optoelectronics. She was responsible for developing extensive material in a high purified vapor phase and liquid phase that led China to become the world leader. Holy F. She was honored as an academician of the Chinese Academy of Science and became the vice president of China Association for Science and Technology. She received the National S&T Progress Award twice and the first prize in CAS S&T Progress Award 4 times. In 1998, she was given the Henry Ford Achievement Award. In the political field, she was selected as a Deputy National People Congress and a member of the Standing Committee. Do you think that she can refuse that? Of course not. Putian, Fujian Province. Born into a large and prestigious family which could be traced back to Ming Dynasty, 600 years before. Her sister became childbridge. Bridge or were killed before she was 6 years old. Lining was required to wash clothes and cook for the whole family. Her ancestor Lin Rong was an imperial censor during the Ming Dynasty. This was an official position that controlled and supervised other government offices. During his career, he faced two influential people who challenged state authority. By helping the emperor deal with these two challengers, the emperor gave him money to build a house in Putian, which now is called the Old House of Lin Rong. At the age 6, she wanted to go to school rather than housework and chatting with other women all day. The only escape was via education. Her mother was deeply influenced by Chinese social gender norms and forbid her to get an education. Ling locked herself in her room and swore that she would not eat until she was allowed to go to school. Her mother was moved by her insistences and finally allowed her to attend Linqing Primary School. Ling often got the best grade in her class, while she was required to do all the washing and cooking. Then came study that often kept her up to 12 a.m. She got up, cooked, and then went to school. Her habit of sleeping 6 hours continued through her life. She fought a similar battle to continue liquid middle school. Her mother said that a female literacy did not matter. She convinced her mother that if she did not need money to study, she could go. The middle school provides scholarship for students who got the 3 best grades each semester. Ling earned her scholarship every semester. After finishing middle school, she enrolled to Putian High School. Her mother finally accepted her study because of her success in middle school. However, Ling stayed in this school for only 1 year. Japan went to war with China and killed many Chinese people. A lot of students became angry and held many parades to boycott Japan. Many Japanese soldiers and agents were in China, so the parade was suppressed and some students were killed. Lin transferred to a women's school called Hanmi Lund School. One of her teachers came from the United States and could not speak Chinese very well, so many of her classmates could not understand his course. Lin helped the teacher as an assistant. When the teacher taught something in English, Lin will translate. Because of this, she was called Little Teacher. She continued her study at Fuqing Christian University, a top university at the time in China. She graduated at age 22 with a bachelor's degree in physics. As one of the best in her class, she worked at the university for 8 years, 4 years as an assistant to teach some fundamental courses such as mechanics. Her first book was Course for Experimental Optics and earned certification as a professor. Education in the United States. Oh my God. And so many opportunities for scientists and including international students. Many Chinese students were not allowed to repatriate. Through the recommendation of her professor at the University of Pennsylvania, she decided to work as a senior engineer in Sylvania Company, which mainly manufactured semiconductors. At the time, the company has failed several times in making monocrystal silicon. Lan Yan discovered the problem and helped the company successfully engineer the silicon technology. In China, after Lin had worked in America for a year, China signed a treaty during the Geneva Conference. Approached her and threatened to withhold her earnings for the year to persuade her to stay. Lynn accepted this and boarded the ship. Her family stayed poor because her salary was only this and $20 a month. Her workplace has little money, however, she never gave up. In 1957, her workplace Institute of Semiconductor cast finished making the first monocrystal germanium in China. By virtue of her experience in Sylvania Company, she knew the process for making monocrystal silicons. However, she could not get equipment because of embargoes from other countries. She changed the process and made China's first monocrystal silicon in 1958. Oh my God. China became the third country to make monocrystal silicon. In 1962, she designed the monocrystal furnace. This furnace was licensed to many countries. In the same year, she made the first monocrystal gallium arsenide in China. The Cultural Revolution intervened in 1963. Suffering from it, all educators and scientists were suppressed. Lynn was not allowed to do research and had to stay in her room under the monitoring of authority. Lynn's educator father died during the assault by young people. Despite the tragedy, she worked at the age 60 after a cultural revolution. She found that the dislocation density of existing gallium arsenide was large due to gravity and not good enough to use, so she decided to make the experiment in artificial satellites. This was a dangerous experiment because the melting point of gallium arsenide is this. However, she finished successfully and became the world's first to do so. A gallium arsenide company, after her in 2001. At the age 78 in 1996, she was diagnosed with cancer. She wanted those years of offset the 10 love for the Cultural Revolution. In 2003 she died. Kiam Chang Wang Chen Lin. No one say it's gonna be easy, bro. No one say it's gonna be easy, bro. Totally. But again, here we are. But again, here we are. But again, here we are. Pathology. Pathology. Anyway. Okay, so now that we look at, wow, that was quite interesting. Okay. This is one of the beautiful things of software engineering, is that now it can give you is this perspective, not only software engineering but also the internet. If you do that in a systematic way, it can give you is now a wider perspective of why you do the thing that you do, first. And second is that focus your attention on what really matters. But in any case, so is this. After we look at the conditional rendering lists here by mapping them and then returning all of the results for that. Okay. And in this case, actually, this won't work. Notice the sandbox above display a console error. Each child in list should have a unique prop. You will learn how to fix this error later on this page, but as you can see, it's this one. and how even you can filter that. All right. Lastly, return the list items as it is. Arrow function implicitly return the expression right after this. So you didn't need a return. Exactly. Unless you're using curly bracket. Keeping list items in order with key. You need to give each array items a key, a string of numbers that uniquely identify amongst other items in the array. JSX elements directly inside a map can always need keys. Keys tell React which array items each component corresponds to, so that it can match them up later. This becomes important if your array items can move, do sorting, or insert, or do any of these operations, as well as choosing keys. Help React infer what happened and make the correct updates to the DOM. So again, all of these ideas should come from the backend. Where do you get your key? Data from database or locally generated data using the crypto.random UID or a package like UUID when creating items. Rule of key. Key must be unique among siblings. However, is it okay to use the same key for JSX node in different arrays? Key must not change, or that defeats their purpose. Don't generate them while rendering. Why does React need keys? Imagine that a file on your desktop didn't have names. Instead, you refer them by their order. The first file, the second file, so on. So you can get used to it, but once you delete a file, it will get confusing. The second file will become the first file, and the first file will become the second file, and so on. File names in a folder and JSX key is an array server a similar purpose as an identifier. Exactly. As an identifier for this. Splitting a list in two. Data, as it is, and then you got the utils, right? Which is something that you're going to apply to this. And then you got to get image like so. Okay. But what we really care about in today's video is this. So what you really care about in this video is this. And that is your UI as a tree. Okay? Why this is important as a way to understand and remember what's going on. Part of the React performance. Your React app is taking shape with many components being nested within each other. How does React keep track of your app's component structure? React and many other libraries use a model UI as a tree. Thinking of your app as a tree is useful for understanding the relationship between components. This understanding will help you to debug future concepts like performance and state management. Okay? So your UI as a tree. Three are relationship model between items and the UI is often represented using the tree structure. So it's the relationship is how all of this is the relationship among these React components. For example, browser use three structures to model HTML, DOM, and CSS object model. Exactly. That's it. Exactly. That's the HTML or the DOM and the CSS Mobile platform also use tree to represent their view hierarchy. So you get is this. So like browsers and mobile platform, React also uses a tree structure to manage and model the relationship between components in a React app. These three are useful tools to understand how data flows through a React app and how to optimize rendering, and app size. So now we finally get it. Something that I'm quite familiar here, especially when I look at other components like Vue or other frameworks like Vue, all right, and how they mount components. But React here is actually following this tree-like structure. Okay, so the render tree is as it is. So a major feature of component is not only understanding how data flows, but also the performance aspect. As a way to identify is that, hey, which one of these components actually triggers a rendering, and not only that, the question is that also actually triggers re-rendering in subcomponents? The intuitions can tell you yes. Let's see if that actually is what it is. A major feature of component is the ability to compose components of other components. As with next component, we have the concept of parent and child components, where each parent component may itself be a child of another component. When we render a React, we can model this relationship in a tree, known as the render tree. Here's an app that renders inspirational quotes. Okay? Right? So now you're able to pass the fancy text here, which is one component, and is also following this peculiar syntax on JSX as a way to say, hey, this is the root element that, if you remember, if you have worked, for example, on with the DOM or with HTML, you also need to always define components in that fashion, or defining just your tag nested. So they cannot be, they must follow this particular structure, the render tree. So, get inspired app. Your inspirational code is, don't let yesterday take up too much of today. Will Rogers. But again, it's now running this component, render this component, as well as all this and other nested components inside of this. Okay, so you in fact is actually rendering is now 1, 2, 3 components. Okay, fancy text, which now is say, hey, I'm going to show is this with a fancy title or a fancy cursive. Inspiration generator, that actually is the logic that fetch that data and update that properly. Okay, anytime you get that, or perhaps it's using some, okay, it's using some quotes that it get this. All right, and as you can see here, the app structure, the app 3 structure is like this. You get the fancy text and you have the inspirational generator, where inside of this you got is a copyright, right? So as you can see, you got the fancy text followed by the inspirator generator. That inside of the inspirator generator, you got here is a fancy text, and below that, it allows you to render now children elements. And below that, it allows you to now render is the copyright component. So this is how you can create a render tree, the UI tree compose. Okay, so this is something important as a way to understand is now the architecture of our components, the render tree. Again, this is something that I know. Okay, this is something that I know, which is good. All right, the question is that, all right, how can we now, I mean, because after all, React is just rendering components. It's all about rendering components. In this case, if we render, for example, inspiration generator, or if we change the state of the generator inspirator, does that affect the children components? Let's find out. So from the example, we can construct the above render tree. The tree is composed of nodes, each of which represents a component. Exactly. App, fancy text, copyright, to name a few, all of our nodes in our tree. The root node in React renders 3 in the root component. What? Render 3 in the root component of the app. Exactly, because this app is actually now is going to render it at the root level, or root components. Usually we define that with document get element by ID root. We inject that our root component, and the root component app is the first component React renders. Each arrow is the 3 points from parent component to a child. So, where are the HTML tags in the render tree? Oh, you'll notice in the above render tree there is no mention of the HTML tag, because this is all about React components. React as a UI framework is platform agnostic. On the React.dev, we show examples that render to the web, which uses HTML markup and UI primitive. But React could just as likely render to mobile or desktop platform, which may use different UI primitive like UI view or framework element. UI view, exactly. Okay. If you're gonna render that, okay, but React app could just likely render to a mobile or desktop, which may use different UI primitive like UI or framework elements. These platform UI primitives are not part of the React. React renders 3 can provide insight to a React app regardless. But again, here we're not considering is the HTML, only React components, because we are rendering is on the browser, and by using is the React DOM. All right, a render tree represents a single render pass of the React application. Exactly. So we can update the app to conditionally render either an inspiration quote or color. Yeah. Exactly. It's fancy. Text or a color. In this example, depending on the inspiration type, exactly. Depending on the inspiration type, we may render fancy text or color. The render tree may be different for each render pass. Although render tree may differ across render pass, these three are generally helpful for identifying what the top level and leaf components are in React app. Top level components are components nearest to the root component and affect the rendering performance of all the components beneath them, and often contain the most complexity. And this is one of the reasons, for example, when people ask you is like, why we don't use context API? Because as long as your application are small, you might go with that. But as your application grows, the problem is that with the context API, since this sit near the root elements, it's gonna re-render your entire application. Okay. That's bad. And if you now have, for example, a table that show exactly, and if you now have a UI that show is a graph, and now if you have and if you have an admin dashboard that show is a chart, and then right below you have a table that show if you 50 elements, and then you also have another element as a sidebar that showing is, for example, is notifications. All right, when you're adding all of this, that makes that okay. I get it. Okay, All right. That's one of the reasons for that. Oh my God. Yep. Yep. Yeah. Yeah. Yep. Got that. Okay. Once you understand is the architecture of, once you understand is the render UI model of React, and why having a context, especially in small applications, can be useful. But if you can imagine, you have an admin dashboard that shows a chart, and it needs to and show a chart, show a real time chart. Okay. uh, let's say you have an hospital admin dashboard. And for example, first you initially look at the first you are able to see is the patient's data. So if you can see is, for example, is the heart rate, the heart rate, life data of a patient, all right, and showing that in a chart, yes. And also you have is now a table that renders 15 a, a table that render is their 15 elements, or their history records that contain 15 elements. And on the sidebar you also have is, for example, a chat or a notification panel that is also is real time. Okay, so for example, you need to go to talk to a nurse, or a nurse requires you to be on the emergency room, for example. As you're going to add all of these little tiny components in your app, if you're using context that usually sit at that usually sit right before the root element, and if you define your app state at that level, at the context, and if one of those states change, you're gonna cause a cascade effect. Okay, you're gonna cause a cascade effect on all of your components, which means that it's going to re-render the entire tree. No. No, no. No, 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 no. Oh my God. Oh, I get it. Oh, I get it. Mm-hmm. Oh my God, that, okay. Mm-mm-mm. Mm-mm. Mm-mm-mm. Mm-mm-mm. Mm-hmm. Okay. Okay. That makes a lot of sense. That makes a lot of sense. Leaf components are near the bottom of the tree and have no child components that are often frequently re-rendering. Exactly. Although render 3 may differ across render passes, these render 3 are generally helpful for identifying what top level and leaf components are in the React app. Top level components are components nearest to the root component and affect the rendering performance to all the components beneath them, and affect the rendering components of all beneath them, and often contains the most complexity. Leaf components are near the bottom of the tree and have no child components and are often frequently re-rendered. Identify this category of components are useful to understand data flow and performance of your application, and this is one of the reasons why we use Redux. Because with Redux, we can not only have a particular slice or a store at app level that hold all of our app level data, and when that state change, whoever component is using that state is gonna trigger a re-render, not at the root level, or not at closer to the root level. And this is one of the reasons why usually why, if you have context, it'll cause a cascade effects. So the idea here is to Redux is re-rendering. So Redux allows you to do that by following is that particular pattern. And then you have now RTG, okay, Redux development toolkit, as a way to provide now a convenient and more unified way of managing that state, and provide you is also a development toolkit that allows you to do time travel debugging, which is great, and also look at what actions are triggered or what actions are dispatched and which component dispatch those actions. Oh my god. Oh my god. Jesus. Jesus. So it is important to understand now the reason of that. The model dependency tree. Another relationship in a React app that can be modeled with a tree app is the model dependency tree. As we break our components and logic into separate files, we create GS models, where we may export components, functions, or constants. Each node in a model dependency tree is a model, and that each branch represents an important statement in that model. If we take the previous inspiration app, we can build a model dependency tree, or dependency tree for sure. Exactly. The root node of the tree is the root model, also known as the entry point file. It's often the model that contains the root component. Comparing to the rendered tree on the same app, there are similar structure but some notable difference. The nodes that makes up the tree represent models, not components. Non-components model like Inspiration.js are also represented in the tree. The rendered tree only encapsulates components. Exactly. Copyright.js appear under the app.js, but in the rendered tree, copyright, the components appears as a child of inspiration. This is because inspiration generator accept GSX as children props, so it renders copy as a child but does not import the model. Dependency trees are useful to determine what models are necessary to run your React app. When building a React app for production, there is typically a build step that will bundle all the necessary JavaScript to ship to the client. The tool responsible for this is called a bundler, which is exactly it's gonna bundle all the necessary JavaScript to ship to the client, the bundler. And those bundlers can be Webpack, okay, client-side tooling overview. Exactly. And those modelers, those bundlers, post-development, testing tool, but this is post-development, testing tools, deployment tools, GitHub, Netley, and Vercel. Damn. Code climate, for gathering code quality metrics, webpack browser extension for performance runtime, GitHub bots for providing more powerful GitHub functionality, up-down for providing app uptime monitoring, and so many more. Some thoughts about tooling, how to choose and get to a particular tool, and the summary. But they don't. The modern tooling, transformation, or bundlers, and optimizations. For example, bundlers, Webpack, and Vite. Exactly. And this is all the things that you need to learn, that you need to know, my friend. Overview of modern tooling. The modern tooling ecosystem. Environment safety net transformation post development. safety net, linters, source code, code formatters, type checkers, transformations, which is the model bundlers. This is a very interesting website as a way to summarize all the things that you need to know. Tools and testing, understand client-side web development tools. Exactly. I think this is part of what, the curriculum? Command line crash course. Package management basics. Introduction to tool change. And deploying your app. And here they describe is React, Ember, Vue, Svelte, Angular. What is this? Tool and testing. Server-side programming. As well as Python. Okay, alright. Tool chains and the inherent complexity. Okay. Well, but in any case. in any case. But now, as your app grows, often the bundle size does too. Large bundle size are expensive for a client to download and run. Large bundle size can delay the time for your UI to get raw. Getting a sense of your app's dependency tree may help with debugging this issue. So, threes are a common way to represent the relationship between entities. They're often used to model UI. 3 represents the nested relationship between React components. With conditional render, the render tree may change across different renders. With different proc value, components may render different children's components. Render tree helps identify what the top level and leaf components are. Dependency tree represents the model dependency in the React app. Dependency trees are used by build tools to bundle the necessary code and ship app. Dependency trees are useful for debugging. Exactly. Dependency trees are useful for debugging large bundle size that slow time to paint and expose opportunity for optimize what code is bundled. So, the question remains. The question is, if a component in React, if you get the following component structure, grandparent, say great grandparent, parent, and child. If a state change at the grandparent component, it will cause to parent and child to re-render. This is due to the React default rendering behaviors. That's what happened. And we'll update only the actual DOM is a difference between renders. You can optimize this behavior using techniques like React Memo, pure components class for class component, and should component update life cycles in the class component. The great grandparent component won't re-render unless either states or props also change. It's like, oh, okay. Okay, that's one of the reasons why it's there. Okay, all right, okay.
Right? So React gives you like, local server is in development mode, and it does things like give you console logs and yell at you about things. And
Okay. I get it. I totally get it, bro.
so now let's talk about how does React do what it does, right? Because
Steve discussed the 3 phases of React rendering cycle: render, commit, and cleanup. React rendering cycles. Render and commit. Oh, here, rendering commit. Before your components are displayed on the screen, okay, state a component's memory. Okay. Responding to event. Now, this is something that I'm quite familiar. Adding interactivity. Exactly. Responding to an event. Alert, click on toolbar. Oh, but this is actually showing is event bubbling. It's gonna show first this and then alert. And then you click on the toolbar. Event bubbling. Interesting. Using arrow functions. Oh, of course, if you define your button that stop that, but run that. Okay. Can event handler have side effects? Yeah. In React, this is done by using a state and component memory. You will learn about that. A state, a component's memory. Components memory. Components often needs to change what's on the screen as a result of the interaction. Typing in the form should update the input field. Clicking next on an image carousel should change which image is displayed by clicking by. It's like local variables don't persist between renders. Change to local variables won't trigger re-rendering. Exactly. React doesn't realize it needs to render the components again with the new data. So to update that, with new data, 2 things need to happen. Retains the data between renders on a closure. I'm assuming that. And then trigger React to render the component with new data, re-rendering. The useState hooks provide those two things. It retains the state, perhaps in a closure, and then when you need that, you need to set that, you're going to call that closure as a way to now update that data and get that. So useState behind the scene must implement its state variable, some sort of closure, reference, useState initial state. If the value you provide is identical to the current state as determined by an object-is comparison, React will skip re-rendering the component and its children. This is an optimization, although in some cases React may need still to code that. React batches states update. If update screen, okay. All right. Read the documentation. Read the documentation, bro. Read the documentation. You can use flush sync for that. Calling the set function during rendering is only allowed for within the currently rendering components. Adding a state to a component. Call useState to the top level of your component to declare one or more state variables. Current state and set function. But to me it's quite interesting. Avoiding recreating the initial state. Resetting state with values. Storing information from previous renderers. Too many renders. Exactly. Set the correct pass down to the event handler. Correct password down to an inline function. This development only behavior helps you to keep components pure. But can I look at the code here of simply useState React? All right, but the GitHub, no. Can I take a look at the useState? What is the implementation of useState in React? Are they using closures? I'm assuming they must be. They must. Otherwise, how do you store that data? Exactly. How do you store that data? You are using is a persistent state. Okay. You're using a persistent state here. I got it. Holy hell. Holy moly. I get it. Mm-hmm. That makes a lot of sense. Mm-hmm. Mm-hmm. That makes a lot of sense. Mm-hmm. 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 Holy moly, bro. Holy moly. So they're using his closures behind the scenes. Why am I looking at this as a way to now make sense of how all of these things works behind the scenes? And now join all of these different missing parts or hard parts of JavaScript so you can now understand what it's doing behind the scenes and you can now be precise when it comes to solve a problem. Rendering code. So when we are looking here at this and the adding interactivity and how they mention is that state a component's memory is because they are using that as a closure. And closure is this nice little features that provide, is this nice bonus features of JavaScript that when you return a function from another function, it create now this, it allows to this function to access to the outer scope from an inner scope. Allow you to access to the outer lexical scope from the inner scope. That's something powerful. All right. And not only by returning is a function, but also by returning is an object with a nested function. Oh my god. It's like, oh my god, that makes a lot of sense. That makes a lot of sense. Okay. That makes a lot of sense. Your component renders the first time because you pass 0 to useState as the initial value for index. It will return 0 and set index. React remembers 0 as its latest state value. You update the state so when the user clicks the button, it calls set index, index plus 1, and index is 0, so it is set index is 1. They still React to remember index is 1 now and triggers another render. Your component second renders, React still use state 0, but because React remembers what you set index to 1, it returns 1 set index instead, and so on. So this is the component model here. Show details, high details, show details and high details. But it's rendered that. It is a good idea to have multiple state variables in their state is unrelated, like index and show more. In this example, because each time you're creating is that choosing the state structure. Everything now is on the dock here. Everything now is on the is here. Away send message. Exactly, same message. Avoid redundant state. Avoid duplicate state. Don't mirror props in state. And avoid deeply nested state. Okay. That's quite interesting, bro. That's very, very interesting. Because at the end of the day, this is a closure. This is a closure. This is a closure. And then you look at this, adding interactivity. Before your components are displayed on the screen, they must be rendered by React. So understanding the step in this process will help you to think about how your code executes and explain its behavior. What rendering means in React, when and why React renders a component, and the step involved in displaying a component on a screen. Why the mechanism. Why one rendering does not always produce a dump update. Trigger, renders, and commit. Makes sense. Trigger, renders, and commit. Okay. Render, commit, and cleanup phase. Trigger a render, deliver the guest the order of the kitchen. Exactly, deliver the guest the order to the kitchen. Render the component preparing the order in the kitchen. A render delivering the guest order to the kitchen. Rendering the component preparing the order in the kitchen. And then committing to the DOM, placing the order on the table. Component kitchen. Okay, render, deliver the guest order to the kitchen. Rendering the component, preparing the order in the kitchen, and then placing the order on the table. Committing. Re-render when state updates. State updates You go to the component kitchen, triggers, and renders. React render your components. React commit changes to the DOM. Epilogue, Browser Pain by Rachel Lee Neighbors. Rachel Lee Neighbors has spent over a decade teaching the world to code. Put time in my calendar, reach my tech career survival. God damn, what the hell is all this? Mm-hmm. Mm-hmm. What is this? Mm-hmm. Okay. Something went wrong. What? Someone deleted it? Mm. Okay. All right. WordPress. Ah, that's interesting. React and Redux. Okay, that's interesting. Trigger renders and commit. And also there's a last state. State as a snapshot. How setting states trigger and re-renders. When and how state updates. Why does not update immediately after you set it? How event handler access snapshot of the state. React executing the form, calculating the snapshot, and updating the DOM tree. In notify to React, notify go and update that. React update the state value, and then now it gives you the form with true. Okay. As a way to prevent state as snapshots. Notice the number of only increments per click. setting state only state in the next render. During the first render was 0, and this is why in that render on click renders the value number is still 0, even after set number 1 was called. React property change number 1 on the next render. Set the number 1. React property change on that. In this renders event handler, number is always 0, so you set state to 1. For the next render, number 1, so that render clicks handler look like this. Exactly. Number, because it's on the next after that. Okay, he's going to evaluate that pretty much like a JavaScript, and then he's going to on the next time it's going to show that. If you put the alert first, but in this case you're now passing that as a task that needs to be in the future, okay, of course he's going to evaluate that first, and then 3 seconds later he's going to throw you that. With that value. Queuing series of states update. Multiple times before the next render. Updating object in state. Local mutation is fine. Objects are not really nested. Write update logic. Write consists update logic with emer. The code you write look like you are breaking the rules and mutating the object. Okay. But first, after all, is important is to understand is now the render and commit things here. React is the waiter who put in the request from customers and bring their orders. This process of requesting and serving UI has 3 steps. So you are the waitress, you are the waiter who put the request from the customer and brings them their orders. Okay. The initial render, re-render when state updates. React renders your component. React commit change to the DOM. React only changes the DOM node if there is a difference between renders. Exactly. If there is a difference between renders, then it's going to update the DOM. All right. Why this is important? Because this is something interesting as a way to understand how this actually works behind the scenes. And how now here
Different, right? It's like this thing doesn't exist. Go put it on the page. Right on. Right? That's
render, commit, and cleanup phase in the case of the development. Because this is now how, okay. This is now how, This is now how trigger, render, and commit. This is now how React performs, okay? How React do its stuff. React rendering, React rendering cycle. Okay, and then React rendering, because after all you need to know what it's doing behind the scenes. React rendering cycles. Okay, it's like oh, okay, makes a lot of sense. Okay, React rendering cycles. First, take a look at, okay. So first, take a look at how React works here, okay, by how now React actually commit to change, okay. But first thing first is to actually understand is your UI. So first, exactly. So first, take a look at how React works here. By understanding the render tree, by understanding concepts like render tree, okay, like this. By understanding concepts like render tree, all right, and then now how render tree and tree dependencies, okay, render tree and tree dependencies, all right. And when it comes to adding interactivity, exactly, what states are, okay, which is after all there are closures. It use closures, okay, something that we know, we're quite familiar with the closures, totally. State a component memory, and then how now it displays, before your components are displayed on the screen, they must be rendered by React. Understanding the process, understanding the step in this process will help you to think about how your code executes and explain its behavior. So understand now the process of how React rendering this element. How React rendering works. Okay, how is the mechanism of React to render? A memory model, which is something that describes a component's memory. Exactly, it's like a component's memory. All right, it uses closures. Okay, and how React renderings, because after all this, that's the idea of understand that as a way to move on to, all right, now how can we optimize the performance and how can we write performance applications in React? Okay, that makes a lot of sense. Okay, so this is render and commit. Quite interesting. Okay, quite interesting. Holy moly. Okay, so now we're slowly understanding is now we're now adding is all of these ideas from Brian Holt as a way to make sense of now how not only what React does, which is rendering components, but the question is that how that renders, how React render those components. And before to understand how React render those components, we need to look is at the architecture, how it is designed. And that is by understanding is the render tree and the import. Interesting. The render tree and the import dependencies. Okay. Now, once you know the design of how now React, how you can add elements with React to the DOM, okay, now we can see how React renders elements, okay. And before that, we look at, you must understand what states are, which is a component's memory, which is using closure behind the scenes as a way to now persist the state of this component. All right, and anytime the user click a button or do any interactivity to that, all right, now it is time to change is this state inside of this closure. All right, makes sense. So the question is that when you change or when your state change, what is doing behind the scenes? You know what I mean? What is doing behind the scenes? And it tells us what rendering means in React, when and why React renders a component, and the step involved in displaying a component on a screen. Okay, why rendering does not always produce DOM updates. Here we go. Let's get into this. First, we're looking at that how now React. Again, I think this storytelling is quite important as a way to understand now how do we get here, and that can also allow us to explain to other people, right? To someone else. Okay. So, because that at the end of the day, that's quite interesting. Right? Yeah. The idea of looking at the React performance is to understand that how you can write is React applications that are fast. Okay. So for that, you need to understand how React works behind the scenes and what React's after all what it's doing, and that is rendering components, which is allow you to now add using the JSX syntax components to the DOM. All right, and now let the React somehow render that. You don't know why, you don't know how. Okay, but first it's important to understand is that okay, how you can now start into adding components to your DOM. How is it going so you can see now this component rendering element, rendering list of elements of components, doing conditional rendering, okay, and also understand, which is this, and also how you should keep if your JavaScript functions pure, as a way to only perform a calculation and nothing more. All right, and how now this particular mindset of creating components, okay, which is, hey, these components will React assume that every component you write is a pure function. Which means that there is no side effect. Which means that pretty much like when I tell you is how much is 9 times 9, you give me the answer, okay, 81, and the next time I tell you 9 times 9, how much it is, 81, that's the entire reason of this, is that given this particular input, you're gonna get always the same output here. Why this is it? It minds your own business. Same inputs, same outputs. So it gives us predictability of this. So React also assumes that. And now that you know, for example, how to print, how to stamp React components in your DOM, right? You can think of this like a stamper, like a rubber stamp, ready for stamp. Okay. So once you know that, then, well, it is also important to understand is now the design, how this is designed, the architecture. The render tree, which is following is that data structure called tree, which is helpful for organize our data. That's the reason why data structure exists, as a way to organize our chaos, our data, okay, in a way that we can now interact with this data in a tree. So you have now the render tree, which is only focuses on the components, and also the import tree or the dependency tree, which focuses on how many of this import you are using, as a way for add some logic to your components, or to use some model bundlers to get rid of that data. But in any case, once we look at this design, then when it comes now to provide interactivity, okay, which is the reason why we're using this kind of frameworks, is to now enrich the web, is that, all right, we're gonna see how now can we respond to events, and now how can we look at the states, which is a concept, which is the components, a component's memory, okay, as a way to now have these magical features, which is not magical at all, that allow us is to store the state somehow, somewhere, okay, and anytime we provide is an interactivity, or we mutate, change the state of that, React behind the scenes render this component. So how now React render these components, okay, is exactly what we're doing here, render and commit. As a way to now understand is how to write this performance React application. So React and commit, or render and commit, is here we're going to see is what rendering means in React, and when and why React renders a component. Okay, the step involved exactly when and why React renders a component, and the step involved in displaying components on the screen, and why rendering does not always produce DOM element. So what rendering means in React is this. Imagine that your components are cooked in the kitchen, assembling tasty dishes from ingredients. In this scenario, React is a waiter, okay? If you can imagine that components are cooked in the kitchen, assembling tasty dishes from ingredients. So in this scenario, React is the waiter who put in the requests from customers and brings in order. So hey, I'm gonna take orders, I'm gonna take gonna take customer orders and bring them to the kitchen. This process of requesting and serving UI has 3 steps. This process of taking the customers taking the customer request and bringing to the kitchen, okay, or in this case is like now rendering a component and then serve that and then replace that if it's needed, is that it trigger a render which is delivered by the guest order to the kitchen. In our case, when we use the set and the state, okay, hey, I want you to now trigger this update for me. It's going to look at the closures inside of that, then brings that, all right, rendering the components, which is preparing the ordering in the kitchen inside of the closure. Is like say, hey, okay, now that I received this, let me see if now what I have to do, and then commit those changes, which is now giving you or serving the order to the table. That makes a lot of sense here, because now these kitchen components, you can think of this as the closure, which is this feature that JavaScript provides to us. Oh my God. Holy F, man. Oh my God. Okay. Okay. Cool. So now this is now the how React renders behind the scenes. And this is something that is doing always a lot. Every time you set an state, it say, all right, I received this request from you. I'm gonna now, which is the triggering, I'm gonna now render the components, okay, and then I'm going to commit those changes. This is from the React. And now we are talking about is how can we, when we're writing our applications, how can we make use of that to create these performance applications, but from the developer perspective? Because first we're looking is at the React as a machines. Okay, this machines works like it is, like a motorcycle, a bicycle, a vehicle, fridge, oven, all right, stove. This actually works like this, all right. Now I want to know is that how am I as a user can make a better use of this, be performance with this. All right. And that makes a lot of sense.
And overall, like how everything goes down, which is it starts out with a component mounting, which is run the function, call the class, right? Figure out
Render function commit and clean out face.
what that original output is. That's the kind of purple section, right? You'll get back some JSX, whether it's the render method on a class-based component or the output on a functional one. Thing to think about. We won't spend too much time on this, but this is kind of like an overall like how everything goes down, which is it starts out with a component mounting, which is run the function, call the class, right? Figure out what that original output is. That's the kind of purple section, right? You'll get back some JSX, whether it's the render method on a class-based component or the output on a functional one. And that will all kind of be there. And then like, cool, with the first one, you don't even need to do any diffing, right? It's like, this thing doesn't exist. Go put it on the page. Right on, right? That's when it happens in the commit phase. And then after that, which is sometimes why using like use effect for AJAX requests or network requests is somewhat like problematic or tricky, because like you wait until you've done everything and then you're like, let's go fetch the data for this component, right? And there's various tricks, like I think like libraries like recquery, use SWR and stuff along those lines. You know, like I think use SWR will like make a ref that it can cache between cycles. It does some like trickery, right? But yeah, the use effect will happen after you've already committed to the DOM, and then like we'll clean up effects which might trigger some stuff. Then, like we said before, in that much simpler version of this, right? A use state or use reducer will go ahead and be the thing that the catalyst for the updating phase, right? We'll figure out what all the changes are. We'll trigger that tree. We'll update the DOM again, and yeah, things kind of continue and go forward like that. But that is a simplified version of the relatively like involved process of figuring everything out, but it is like, mount the first time and what changed.
Mount the first time and what changed. Yeah. It can be summarized in
of the relatively like involved process of figuring everything out, but it is like, mount the first time and what changed.
It can be summarized in mount. It can be summarized in mount the first time and what changed. Okay. Pretty much like that. Okay. Okay.
The other one is we'll use them today is use memo gets set that very first time, and then callbacks are kind of pulled in. You've never used those hooks before. We'll use them a lot. You will use them by the end. How about that? That is the kind of like situation we find.
Mounting and updating and watch for events.
Find ourselves in that we are going to be able to deal with. And like under the hood, while this is all happening, from 16 later, which is really close, what's related to fiber. Fibers are just a data structure where it keeps track of component interests, its siblings, all those things, try to figure out how to optimize this as much as possible. This is why stuff like keys are important. This is why the general kind of other advice that I would give you is, like, for instance, if something is mostly the same, but for some reason you're like, I've got this crazy trick where I'm going to switch it from a div to a span, like, those are the things where React's like, I don't even know what's going on anymore, right? And so, for some reason you're like, I've got this crazy trick where I'm going to switch it from a div to a span, like, those are the things where React's like, I don't even know what's going on anymore, right? And so, this is a piece of programming advice I want to give you, which is that really fancy stuff seems really cool, and like the kind of more explicit stuff is like on a long enough timeline, almost always better for both the computer and your friends. But yeah, fibers are how kind of React wires this all together. It's this data structure we can keep the kind of previous iterations. It has a structure that's looking at. This is why I say like the whole like, oh, it's just like a virtual DOM thing is like less and less true these days. It's actually, it's grown a bit since 2013. Imagine that, like frameworks changed over like almost a decade now, right? So yeah, there are lots of things. This is why the keys are important. It's like, what would the order, do I need to throw away this entire list or table or what have you? Can I just insert one DOM element? Because sometimes, I did this course on JavaScript performance a long time ago. But like sometimes it's actually cheaper when you're updating the DOM to just blow away an entire section and put it back, right?
Fiber.
Sometimes it's cheaper to just add one to the end. And so if you do not give React the information that it needs, it cannot make good choices on your behalf. And then you're like, React is slow. I'm like, is it React? Or are you making poor choices, right? So like understanding that like there are like complications and that the like whole process in which it does this is not magic is important.
I might just be misunderstanding, but were you saying like semantic HTML is worse than just divs for React, or the other way around?
No, I'm saying if you like came up with some really fancy technique of like, in this moment I'm going to change it from being a div to a span for this reason, it's going to throw it out, right? Like semantic HTML, great, consistently semantic HTML, like weird dynamic programming thing that you did to impress your friends.
Out of place.
Yeah, is almost always going to confuse
Out
the
of place.
very delicate set of heuristics that has been fine-tuned over the last 9 years to help you.
So one or the other throughout.
Yeah, just like the fancier you get, the more you are walking on the edge.
Is there a reason not to auto-assign a unique key, at least to handle the remove and change order to any list?
As long as it's consistent, right? For instance, like, bad ideas, math at random, but like, okay, right, that's a ridiculous bad idea. Other bad ideas, the array index, because that will change every time the array changes, right? That one seems like, oh, I don't have one, I'll just use that to get React to be quiet and leave me alone. But like sometimes we have, situations where it's like, if you're usually getting something from an API, you usually got some kind of idea to work with, right? But if you don't, then, to your question, the right thing to do is around the time you get that array or collection or whatever, assign everything in their unique identifier. Like map over it first before I enter the React component. Give them all, like even a standard integer that's not going to change based, on the where it is in the array, or UUID, or grab the nano ID like library. Just if you need to give stuff, if it didn't come for you with some way, shape or form, like it was just an array of strings that couldn't have duplicates, right? Go through them first and maybe like map them into an object that's got whatever that string was, and then a unique ID, right? And that will, especially if it's changing in any way, shape, or form. Which like on a long enough timeline, assume anything like when you first wrote the code, like this array never changes. If you're doing this more than 3 months, it's changed on you, right? Like, so yeah, I think grabbing it first and like putting a unique identifier for something in some way, shape, or form. I said this in the previous one. I got bit by this one time. We had actually an API with a unique ID, and for some reason, somebody else on my team had used the name of the templates, because it was a list of templates, the name of the templates as the key, but you could have two of those. You could have two templates with the same name, and it wasn't until I was like, we were doing a migration thing, and I had to like reinvent the thing. I was like throwing a bunch of dummy data at it, where I had multiple ones, and like React went into a weird mode where like things weren't changing or moving, and it didn't know what to update when, because I had two with the same unique identifier. And I thought I had found some unique bug, and then went into a weird mode where like things weren't changing or moving, and it didn't know what to update when, because I had two with the same unique identifier. And I thought I had found some unique bug, and then my teammate walked up to me, looked at my screen, pointed at it, and reminded me of those. But like above and beyond performance issues, you could also end up with like things aren't changing the way you thought, and you're getting no error messages.
I run into similar examples of like, I think it's a unique ID, but it turns out under some circumstances it's not. Like if you do a search and the search result array comes back, and there might be a link to the page for that search result, but if there are multiple matches on a target page, and they both come back as a different search result because they match different parts of the document, they might have the same identifier. So good scenario to, when you get the API response, just uniquely identify each element and then render.
Exactly. If you don't get the unique thing, then you can give it to it upon receiving it and use that to track it. Yeah. Mark.
So we need to be very careful with the context API as it lifts the state up. Rewrite.
Yeah, we're gonna spend like a whole hour on that one. I'm gonna do the spoiler alert. I'm gonna just spoil it now. We're gonna do a bunch of things to make an app render less, and then we're gonna add the context API to it, and then we're gonna start over. So like, not, as we're going through that initial one, just don't get your hopes up. All right. So yes, the question was like, does the context API, which then sits literally, if you think about where you put those providers, you put it around like the application component, right? So they will trigger all sorts of things. Now, there are ways to solve for this, and like one of the things that you'll notice that like a lot of the other like larger libraries don't have these problems. Like let's say hypothetically, like I'm gonna use context API, I'm gonna use like use reducers like my own. I don't even need Redux, right? You'll notice flashes of green everywhere, and you'll notice you install React Redux, it doesn't. One, it's just optimized more than you did. Have these problems like let's say hypothetically, like I'm gonna use context API, I'm gonna use like use reducers like my own. I don't even need Redux, right? You'll notice flashes of green everywhere, and you'll notice you install React Redux, it doesn't. One, it's just optimized more than you did the very first thing, and then two, in React 18, like it is like Redux is structured differently insofar as it's store external, and so it's not necessarily like using all the hooks to trigger stuff. It's actually using a completely different hook called use sync external. It just be use sync external source. I can't remember off the top of my head, even though I've read the word 1,000 times. But it actually uses a different API, right? That is mostly meant for libraries to interact with, right? You could totally use too, and if we have free time at some point, I'll show it to you. But like, yeah, using a context API, then you get a new set of things. Luckily, in this workshop, if I might sell you on sticking it out with me, we will run into that issue, we will address that issue, and we'll solve that issue, and then we'll break it again, and we'll solve it again. Right? Fun times. All right. Speaking of questions coming in that like set me up for making promises, like I said before, we talked about automatic batching, so I won't spend too long on it now. But in React 18, and if you notice, if you just bump up your React 18 from 17 to 18 in your package JSON, you will immediately get yelled at. Without polite warning in the console, which is like you're using like React DOM.render, you need to use like create root, and then from that root render it, right? That is an API change that actually opts you in to like effectively some new functionality that gets you this. So if you use, I guess the other like it depends on like do you get automatic batching is if you've chosen to upgrade to React 18 and ignore that suggestion, then no you don't because you're still using React 17 earlier's React DOM like implementation, right? So like you get automatic batching if you use the like recommended concurrency supporting version of mounting the initial root node. Mark.
Just a clarification on how this works. So is React rendering each component and then saving the result of it, and then when it re-renders, kind of comparing the two?
Basically, yeah. Concurrency supporting version of mounting the initial root node. Mark.
An automatic batching introduced. Okay. An automatic batching introduced. An automatic batching introduced. Okay. An automatic batching introduced. An automatic batching introduced. Managing the state, reacting input with the state, choosing the state structure. Principle for structuring. Avoid redundant state, avoid duplication state, avoid deeply nested. Sharing state between components. Lifting state up by example, a single source of truth for each state, exactly. Preserving and reserving state, tracking logic with a reducer, passing data, scaling up with reducer and context. And the scap. Referencing value with ref, manipulating the downward ref, synchronizing with effect. You might not need an effect. Separating event from event. Removing effect dependence, reusing logic with custom hooks. Exactly. Reusing logic with custom hooks. Yeah, something that I'm quite familiar with. Exactly. All right. Okay.
Just a clarification.
But it doesn't tell you automatic batching. But it doesn't tell you anything related to the batching or automatic batching. Oh, but it's from the block. Okay. Oh, but this is from their block. Update strict mode. Configuring your test environment. Dropping support on internet. How to upgrade. Update the server rendering APIs. Render to node stream instead from streaming in node use. Update to TypeScript definition. Okay. They embrace TypeScript. And automatic batching. So out-of-the-box performance improvement by doing more batching by default. Batching is when React groups multiple state updates into a single re-render for better performance. Before React 18, we only batch updates inside React event handlers. Update inside of promise, set timeout, native event handlers, or any other event were not batched in React by default. Starting in React 18 with create root, all updates will automatically batch. With create root, all updates will automatically batch no matter where they are originated. This means that updates inside of timeouts promise inside exactly means that update inside timeouts promise native event and any other event will be batched the same way as update inside of React event. So React will only re-render once at the end, and that's batching. React will only re-render once at the end of that's batching. Okay, you got all of this batch of actions. No, this is okay for rendering performance. New API for libraries. Use sync external store or use insertion effect. That's quite interesting. That's quite interesting.
So is React rendering each component and then saving the result of it, and then when it re-renders, kind of comparing the two?
Basically, yeah. So the question was
each component and then saving the result of it, and then when it re-renders, kind of comparing the two.
basically, yeah.
So you're gonna save all of this state change, and then lastly, gonna re-render that component.
So the question was, it's like it's saving the output from last time, looking how it's changed. Like that is how it collects all the data for the commit phase, right? Awesome. On the topic of the automatic batching, which is before React 18, there was a way to I forget the name, it was like unstable underscore batch updates. That might have actually been the name. And you could use that, and like React Redux used it, other libraries used it. Like in the same way that before there was the context API that we all know and love, there was a always legacy, never fully supported, always unstable one that all these libraries used originally as well. And so there's this one that those libraries used. Now that it's supported in React 18 for everyone, I guess sometimes you need to, for some reason, give people the opposite. So if you, for some reason, need to get out of automatic batching, which you better have a real good reason. Like when that PR lands on my desk, I'm gonna have questions for you. And if it's like, I totally need it for this very the burden of proof is on you to use. It's like, look at how the docs even frames it. Like, it starts out with a big warning thing. Using flush sync is uncommon and can hurt the performance of your app. The burden of proof is on you if you choose to use this one. But I just want to, do my due diligence to make you aware that it does in fact exist. If you need it, I've done my job. I've told you about it.
Okay.
Speaking of, questions, external.
Fibers and key, but it's interesting because it doesn't tell you anything related to fibers. Dropping support for Internet Explorer. Rest in peace. React DOM. Deprecations and other breaking chains. Consistent use effect timing. Strict height rotation errors. Suspense 3 and R are always consistent. Layout effect with suspense. New JS environment requirement. Symbol and object are assigned. Other notable change, component cannot render undefined. In test, act warning are not opt-in. No warning about set state or unmounted component. No warning about set state or unmounted component. No suppressing of console log, improved memory use. React now cleans up more internal fields and unmount, making the impact from unfixed memory leaks that may exist in your app code less severe. Oh, memory leaks. You are not handling memory right. It's like you are creating all of these objects, but you are not letting the garbage collector to actually remove that, or making them available, making those space that those objects are taking in memory available. You're not doing that. And the full change log here. I think this is all of the 18, right? Okay. React 18. There you got it. React 18 release post. Oh, and release post. What is concurrent React? Readily adopting concurrent features. Suspending data frameworks. Server component is still in development. What's new in React? Automatic batching, transitions, or this concept of low priority re-rendering, right? Start transition or not. New suspense features, new client and server rendering APIs, React DOM client, React DOM server, new strict mode behaviors, new hooks, use ID, use transition, use defer value, use syncs external store. Is a new hook that allows external store to support concurrent reads by forcing update to store to be synchronous. It removes the need to use effect when implementing subscriptions to external data source, and it is recommended for any library that integrate with stay external to React. Use insertion effect. That's quite interesting. New client and server rendering APIs. New suspense feature. New features transition. What's new in React 18? Automatic batching, transition, new suspense API, new strict mode behaviors, oh, interesting. That's quite interesting, man. That's for sure quite interesting, man. Totally. Okay, holy moly. This is React 18. This is the first time, by the way, I read the React documentation. Okay. React docs. Like React 18 blog. Okay. First time I read about this. That's quite interesting. And how to upgrade that. And the upgrade. Okay. And the upgrade React 18. That's very, very interesting. All right. Okay. Good. Okay. Good. Good, bro.
I just be using external source. I can't remember off the top of my head.
So now when we look at this on this concurrent React, concurrency is not a feature per se. It is new behind the scenes mechanism that enable React to prepare multiple versions of your UI at the same time. You can think of concurrency as an implementation detail. It is valuable because of this feature that it unlocks. React uses sophisticated techniques in its internal implementations like priority queues. Priority queues which is a special data type, priority queues, and multiple buffering. But buffering is not this. Buffering. Multiple buffering. Multiple single buffering. Double buffering. Triple buffering. And then draw, and then draw. Okay. Oh, oh my God. All right. Triple buffering with frame B delay. Double buffering. It's taking copy of this, and then it's gonna show you that, and then it's gonna draw that. Buffer and video memory as a way to load all of that. That's actually work like that? Buffering. We actually don't see that kind of things like buffering. That's a relic of the past. But priority queues is a data structure here. You will see this concept anywhere in our public API. When we design API, we try to hide implementation details from developers. As a React developer, you focus on what you want the user experience to look like, and React handles how to deliver that experience. So we don't expect React developers to know how concurrency works under the hood. However, concurrent React is more important than a typical implementation detail. It is a fundamental update to React's core rendering model. So while it is not super important to know how concurrency works, it is maybe worth knowing what is at a high level. A key property of concurrent React is that its rendering is interruptible. When you first upgrade to React 18, before adding any concurrent features, updates are rendering at the same as previous version of React in a single, uninterrupted, synchronous transaction. With synchronous rendering, once an update starts rendering, nothing can interrupt it until the user can see the result on the screen. In a concurrent render, this is not always the case. React may start rendering an update, pause in the middle, then continue later. It may even abandon an in-progress render altogether. React guarantees that the UI will appear consistent, even if a render is interrupted. To do this, it waits to perform DOM mutation until the end. It waits to perform DOM mutations until the end. Hey, I want you to do all of these things concurrently, but at the end of the day, I'm going to then perform that. So once the entire tree has been evaluated, with this capability, React can prepare new scenes in the background without blocking the main thread. This means the UI can respond immediately to the user input, even if in the middle of a large rendering task, creating a fluid user experience. It's like by doing this, you can prepare, you're kind of prepared. You're kind of prepared for that. Another example is reusable state. Concurrent React can remove sections from the UI from the screen, then add them back later while reusing. Concurrent rendering is a powerful new tool in React, and most of our new features are built to take advantage of it, including suspense transition, streaming server rendering. Remember that at the end of the day, this is a Facebook technology designed to solve Facebook problems. Most of us don't have that. And if you have the kind of problems, please send me a check. Gladly to help. Okay. All right. Okay, but here there is nothing like fiber. No, I don't think anything related to fiber.
I've read the word 1,000 times. But actually uses a different API, right? That is mostly meant for libraries to interact with, right? You could totally use too.
React Fiber, but that's to me quite interesting. Even though when I try to React Fiber, even though when I try to find here, it's like, yeah, but where do you get this? I mean, all of that they're going to do is circle your keyboard. Mm-hmm. I mean, this is React 16 Fiber. See, React 16 block. But this is from React 16. Okay. Oh my God. Okay, okay. Now this actually comes from the past. React rendering cycle, React Fiber and rendering. React Fiber. Makes sense. React Fiber and rendering. That makes a lot of sense. That makes a lot of sense. Okay. In version 16. No core concept. Okay. Okay. All right. Holy moly. Okay. That makes a lot of sense.
And if we have free time at some point, I'll show it to you. But like, yeah, using a context API, then you get a new set of things. Luckily, in this workshop, if I might sell you on sticking it out with me, we will run into that issue, we will address that issue, and we'll solve that issue, and then we'll break it again, and we'll solve it again. All right? Fun times. All right. Speaking of questions coming in that like set me up for making promises. Like I said before, we talked about automatic batching, so I won't spend too long on it now. But in React 18, and if you notice, if you just bump up your React 18 from 17 to 18 in your package JSON, you will immediately get yelled at. Without polite warning in the console, which is like you're using like React DOM.render, you need to use like create root, and then from that root render it, right? That is an API change that actually opts you in to like effectively some new functionality that gets you this. So if you use, I guess the other like it depends on like do you get automatic batching is if you've chosen to upgrade to React 18 and ignore that suggestion, then no, you don't, because you're still using React 17 earlier's React DOM like implementation, right? So like you get automatic batching if you use the like recommended concurrent C supporting version of mounting the initial root node. Mark.
Just a clarification on how this works. So is React rendering each component and then saving the result of it, and then when it re-renders, kind of comparing the two?
Basically, yeah. So the question was, it's like it saved me up from last time, looking how it's changed. Like that is how it collects all the data for the commit phase, right? Awesome. On the topic of the automatic batching, which is before React 18, there was a way to like, there was like, I forget the name, but like unstable underscore batch updates. That might have actually been the name.
All right.
And you could use that, and like React Redux used it, other libraries used it, like in the same way that before there was a...
Holy moly. Anyway, that'll be all for this video. Take care. Bye-bye.